Good morning, Paramount School of Excellence. Today is Friday, April 7, 2017. Please rise for the Pledge of Allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Today's weather will be windy with a high temperature of 53 degrees. We will have indoor recess.
Today's lunch will be pizza with orange glazed carrots. Monday's breakfast will be a chocolate chip bar with goldfish and apple juice.
Thank you, students, for helping with the announcements. The weekly morning riddle has been solved, and the answer was a siren. Our winners this week were Mary Hebel and Hannah Bolton. Today is also a special edition of the announcements. The previous four students, Mason Pearson, Alex Stroop, Mary Hebel, and Alexis Wilson, were part of a NASA program where they designed a parachute that could land on Mars. They helped design and test a model that could work in real life. Yesterday, they represented Paramount School of Excellence as they got to present their design to NASA at the Children's Museum, and today we're going to watch their video. Congratulations to our students on a successful project. I'm very proud of you all.
This is Team Space Invaders, and we created a solution to the Parachuting onto Mars Engineering Design Challenge. Our video title is Successfully Landing on Mars.
There are 8 steps to creating a drag device. Here are the first 2 steps. Step 1, identifying the need or problem. We had to work with the criteria and constraints, asking ourselves how can we design a drag device? What general scientific concept did we need to consider? Step 2, researching the need or problem. We had to conduct research about who else was working on drag devices. Then, how our society will benefit from it being solved.
Step 3, develop the possible solutions. In this step, we made a sketch of some possible solutions. We didn't share our ideas until after, which we used for step 4. Step 4, select the best possible solutions. In this step, we shared and critiqued our works. We had a checklist that we answered yes or no to and elaborated our answers.
When I started constructing a prototype, it was probably the best part. I got to use ideas that we came up with to create something that would actually work. We came across multiple challenges, but one of our biggest challenges was trying to keep the strings attached to the parachute.
About this. We'll have to tape around this part so it won't funnel out. So in case of some pipes it'll fall out, so we might need to put tape around it. As long as it doesn't fall, it's fall. But when it's landing, that's actually a very good part.
And then that's under it, so the paper plate, so this alone would be like right here, then the strings would be going through it.
Yes, the strings would go from the paper plate to this.
So we're going to need how much string? How many inches of string?
I don't know.
Probably 6, maybe 8 inches.
Well, at least overestimate instead of underestimate, because then if we underestimate, we're going to have to buy more.
Step 5 is pretty fun, but here's some of step 6. Step 6 was almost as enjoyable as step 5. During step 6, nothing broke, and a little bit more. We got a high time of 4.37 seconds and a low of 0.96 seconds. We'll be moving on to steps 7 and 8.
Step 7, communicate. The solution we had to test, and test again to collect all the data we needed to challenge one another, to go back to the drawing board and redesign.
We have our design right here. So we have like a paper or like a styrofoam plate with holes in the bottom attached to a shower cap. We took a paper bag and like straightened it so it's flattened out.
The reason we cut out the paper bag and kind of did this because we didn't have enough drag of just this, so we decided to add this.
Step 8, redesign. We had to return it many times to collect other materials, plus modify our parachute. After many tries, we did it. Our ship landed with grace and our weight was within the 50 milligram constraint at 20 milligrams.